Welcome to this IQON Knowledge and Innovation film. IQON is a series of films that are designed to be watched on demand at any time that suits you. Each film is aligned to the IQ Skills Wheel, the tool IQ uses to help its members develop their all-round professionalism. This film is part of the Knowledge and Innovation segment of the Skills Wheel. This is a segment that looks at the technology and the processes that drive the industry forwards. In this film, we will look at all sorts of innovations that are being developed to support our industry. From technologies that you are perhaps already familiar with, such as drones and telemetry, through to autonomous vehicles and harnessing big data to make significant impacts on efficiency and safety of our sites. The use of technology has a number of implications that we need to think about in planning for the future. What do we identify opportunities that are best suited for digital transformation? Are some areas more readily suited to technology than others? How do we create the culture where innovation and the drive towards technological solutions can be found and successfully implemented? What training and support should we be providing our teams to ensure they are able to embrace the opportunities that technology brings? What are the barriers stopping organisations investing in tech-based solutions? How does the use of technology impact on the mix of skills we need to operate both now and in the future? To help explore this topic, we will be speaking to Levi Hamilton, Director at Delabole Slate, and looking at all sorts of solutions that are already in place in development with key industry suppliers. The use and adoption of technology is progressing at an ever-increasing rate. You may have heard the term Industry 4.0. What does that mean? It's the fourth industrial revolution. Industry 4.0 goes beyond the automation of single machines and processes and looks to integrate the whole business network through data in order to create greater value for employees, suppliers and other partners, and of course their customers. And this is an important point. Technology adoption is increasing at a rate faster than ever, and with the changing demographics in the workplace, there is a greater expectation for all businesses to engage with digital tech. This will be crucial for recruiting and retaining talent, as well as building solid relationships with customers. So companies are using tech to rethink their operations. Why? Well, the combination of more data being gathered, the cost of computing power being more affordable, and the widespread availability of mobile tech means that decision making can be done on the go, all of which means there is a more powerful case to increase operational performance. Businesses that lead the way in transforming their operations and the products and services they offer will be more competitive and better placed to deal with future change. The Stone Age didn't end because they ran out of stones. They progressed and advanced as knowledge and technology moved forward. From smart houses to self-driving dumpers, the application and integration of technology is being embedded in our everyday lives. The minerals products sector has a rich history of embracing technology and working practices, but digital transformation will provide the biggest step change the industry has seen in more than 100 years. These changes are reshaping the way the industry functions. Their use assists in delivering increased levels of safety and employee welfare, as well as a positive, meaningful impact on efficiency and productivity. Major advances in autonomous processes, robotics, electric-powered vehicles, and telematics are all being brought to the forefront in the industry. As these technologies develop, it becomes easier to visualise how these technologies will feature heavily in the future. To start, let's consider the difference between a machine and a robot. While all robots are machines, not all machines are robots. Ultimately, what sets a robot apart from a machine is its ability to be programmed to undertake complex tasks and to operate, at the very least, on a semi-autonomous level. Whilst the drone may appear to be robotic, the process is still controlled by the operator. Although they can carry out a series of tasks, most commercially available drones are controlled remotely and are unable to perform those tasks without human interaction. Robots are already entering parts of the industry in the form of autonomous rovers equipped with high-definition cameras and light imaging detection and ranging, or LiDAR sensors, allowing them to navigate their way around sites and are able to identify and avoid obstacles. Volvo has been developing a suite of concept machines as part of their electric site research project. This project aims to transform the quarry and aggregates industry by reducing carbon emissions by up to 95% and the total cost of ownership by up to 25%. Volvo's vision is to electrify transport in a quarry, from extraction to primary crushing and transport to secondary crushing. It involves developing new machines, work methods and site management systems which together form a complete site solution. Vehicles include the HX2 dumper, an autonomous battery electric load carrier able to carry twice its weight in load and has a charge time of just 60 seconds. As well as a small fleet of HX2s, other prototype machines that make up the electric site system include a prototype electric hybrid wheel loader and a grid-connected excavator. Additionally, new technology encompasses machine and fleet control systems along with logistic solutions for electric machines in quarries. To testbed the autonomous and semi-autonomous machines, a Volvo CE teamed up with its customer Skanska Sweden, the Swedish Energy Agency and 2 Swedish universities to collaborate on the 203 million Swedish krona project. The project set out to turn the quarrying industry on its head by creating the world's first safe, productive, sustainable and emission-free quarry. The application of technology is also making waves in training applications. Sandbox environments are created in both virtual and augmented reality, which allows individuals to experience simulated environments and equipment whilst avoiding any of the health and safety issues and unnecessary costs associated with traditional training approaches. Competent machine operators will always deliver a profitable return on your investment. They will help lower the production cost, improve fuel efficiency, reduce environmental impact and enhance site safety. The training systems currently available are all based on data from real machines, set in authentic working scenarios, providing real-world experience, but with zero fuel consumption and avoiding any dangerous or hazardous situations that may be caused through an operator's inexperience. Undertaking learning elements in a digital space ensures people are prepared and ready for when they find themselves in real-life scenarios. Teaching people to avoid danger by immersing them in a safe, controlled learning environment helps to reinforce safety procedures and enables them to recognise unsafe environments. It also allows them to make mistakes and see the consequences of actions in a simulated environment. Owing to increasing accessibility and time-saving benefits in various applications, drone technology has become widespread in its use throughout the sector. With the advanced platforms available behind the hardware, data behind the images can fully be harnessed and meaningful analytics extracted from them. This results in stockpile calculations being completed as easy as clicking on the top of the pile, choosing the volume calculation method and assigning the type of material. This level of inventory management is one of the main value points of the technology. Accurate assessment of what is currently on site can be completed easily, drastically reducing the time needed to be able to complete the job. On average, drone surveys will yield 350 times higher resolution imagery than traditional survey methods, and are up to 50 times faster, providing comprehensive surveys in hours instead of days, and the facility is there for this to be repeated as often as required. They are also often utilised for environmental monitoring, providing site information to better plan and manage operations, and also allow site visuals to be created and displayed as high-resolution surveys, slope maps, digital surface models, or in 3D. Ultimately, every stone counts, so maximising vehicle equipment performance is where data and analytics can support decision making. Enhancing accuracy and efficiency of operators can be achieved through the integration of smart technologies, helping us to reduce operational downtime and increasing productivity and safety. Machine connectivity can provide data that helps keep operations running smoothly. Telematics-based analysis provides concise, Reports keeping you informed of the essentials, showing you how much each machine is being used and where each machine is located. All modern machines have sensors, which will relay everything from fault codes to fuel consumption, and if any fault codes occur, it will automatically be sent to the local dealer so that they can arrive on site with the necessary equipment. Telematics can also assist in identifying poor operator habits where further training may be needed. For example, riding the brakes, overloading or erratic operator behaviour can all damage the machine or cause premature wear. Raising awareness of this provides the opportunity for improved operator behaviour, which can improve productivity and ensure the work environment becomes safer. In short, what gets measured gets managed. Geolocation technology enables vehicle tracking and ensures efficient equipment flow and safe operations, whilst real-time analytics provide the platform for operational status to be monitored from a smart device anywhere, anytime. It also allows progressive improvements of workflow efficiency and connected diagnostics to be monitored. All in all, these systems provide a platform to assist in maximising productivity, minimising downtime, and help to maintain equipment at peak operating performance.
One thing technology is going to do, it's going to be producing a lot of data, and people are going to need skills in order to use that data. It could be process improvements on quality, health and safety, downtime. So you've created a lot of data with your telemetry project. How did that change some of your processes? How did you use that?
So essentially we review all the telemetry data weekly, and we actually review it with the management team of the site, and then we also review it with all the employees on a weekly basis. So that's a good forum for ideas to come up and challenge the reasons why we've got low throughput for whatever reason. So essentially in the management meetings we would look at why the tonnage has dropped below the optimum, and then the comments would align with what essentially we need to do about it. Now some of these examples range from simply ensuring brake covers are covered. One thing we noticed on the recycling plant is because the recycling plant doesn't have a surge pile as such, it's literally fed by a machine. When those operators would brake from their post, if you like, go to brake, there would be a gap. And this gap could be worth 50 tonne an hour, 25 tonne an hour, which all holds a value. So what we decided to do was we reallocated brake times. From non-critical operations, we pulled them off to make sure the plant was fully loaded at all times. So we're not burning empty, if you call it, kilowatt hours. So we're always capitalising on the throughput. So when the plant is running, it's always fully loaded. Another thing that we did on the recycling side, due to its lack of capacity to hold feed material, we put a sensor in the hopper. So this sensor is a radar sensor from one side to the other, and when the hopper falls below 30%, a red light flashes, and the red light indicates to the loading shovel operator or the excavator operator, if they're, in the case of the loading shovel, loading a wagon or a HGV, when the light flashes, they know they need to redivert their attention to make sure they go back to the plant to make sure it's loaded. So it was kind of a simple indication to the operator so that they know they've got some time so that the plant doesn't run empty. So a low-level sensor. One of the other sort of engineering controls that we had to implement was on the bottom of one of the screens. There is a chute, and inside the chute it has various little shelves. And the idea of the shelves is that the material goes into the chute, and it's a rock-on-rock effect to reduce wear. But as we increased the throughput, these shelves were causing the material to back up and then fall into the next chute, causing contamination. So going back to risk, wasn't a good situation we had there. So we removed the chutes, we simply cut out all the rock shells, then lined it with stainless steel, 8mm thick stainless steel. So that allows the material to flow down both chutes very quickly, without any blockages. So again, that was one of the bottlenecks that was always coming up when we tried to strive for the higher throughput.
When you're creating key performance indicators, or you're trying to measure the success of an innovation or a new technology, you need a bit of flexibility. It needs to fit with your business strategy, but new innovations can take time to take full effect.
Yeah.
And you need a certain amount of incubation.
Yeah.
You need to protect that idea, to let it come to fruition and give it some time. I think you gave an example of you did that in your project.
Yeah, I mean, essentially, the whole telemetry, static plant telemetry, remote monitoring, whichever you want to call it, project itself, had to have some time to gather some data from the operation before we jumped in and started fixing things. Because essentially, if you jump in straight away, you might be jumping in at the number 10 out of the 20 problems that you might have, where actually if you wait a little bit longer, you're going to be seeing the top 5. So you're aligning your investment to the not so critical. So I think it is definitely key with these innovations to give them a bit of time to sort of bed in, and also the corrections that you make to the process, they need a bit of time to be able to see whether they're fully working. And I think there maybe sometimes is a bit of a problem that people maybe be sceptical and jump in too early before it's actually been given time to really bed it in. And even the corrections that we do make may be the right thing to do, but they've been executed potentially the wrong way, and they need to go back to the drawing board and say, right, we do need to still do something about this, but we're going to use a different product or a different supplier, or we're going to come at this from a different angle. No matter their size, organisations constantly look to increase productivity, efficiency and performance through increasing revenue and reducing costs. The implementation of new technology can help to achieve these aims, but how the technologies are introduced can make or break the level of success achieved. A study at MIT Sloan Management Review reports that 63% of managers believe that the pace of technological change in their workplaces is too slow, with the most cited obstacle for digital transformation being the lack of urgency. They also said that the benefits of newly introduced tools are poorly communicated. This is really important because building a progressive digital culture means working with employees to help identify, evaluate and adopt new technology seamlessly. No matter what technology is chosen to drive progress and efficiency in your organisation, there are steps that will help set the stage for a successful transition and implementation. Here are a few tips for getting the most out of a technology rollout. 1. Start with the process. What's not working? What do we want to change through the technology, and how will its success be measured? Then rank your priorities. Functionality and cost are important, but make sure that user compatibility is also considered. Systems should be accessible and intuitive to use. 2. Provide full support. Once a technological solution has been chosen, make sure that there is a complete support system in place to help with the transition. This should include an ongoing approach to training that continues to help employees use the new technology. One-off training sessions and thick user manuals are rarely a recipe for success. Consider bite-sized digital training that can be accessed whenever it's needed. 3. Don't rush. Artificial deadlines and the urgency to show a return on investment can lead to poor implementation. Poor implementation will cause employees to lose faith in the new system and it will fail. 4. Be transparent. Understand that any new technology will bring unexpected events and friction. Being open and honest with employees keeps them informed as to what's going on and reassures them of their role in the implementation process, which ultimately helps with the transition. 5. Build value. Communicating openly with employees also helps to explain why the change is being made, reinforces the benefits of the new technology or process and highlights what the potential risk or failure is. Give collective ownership for the success of the project, value their opinions and give feedback. 6. Maintain momentum. Initial success can run out of steam once the implementation phase is over. To make sure the new technology continues to deliver benefit and value, put an individual or team in charge of overseeing the process from start to finish. including monitoring ongoing usage after the implementation phase is over.
I think a lot of quarry operations have to be very highly controlled to maintain health and safety, to maintain quality of product. But sometimes to achieve or to aim for innovation, autonomy has to be brought in as well, and this has to be balanced, and it's a difficult balance to make. There's a balance to be made between exploitation and exploration. So exploitation is the current profit engine of the business. You've got to make sure this is efficient, you've got to support this. But then there's also exploration, which is the testing, the experimenting, trying new ideas out in a way that you can iterate them without damaging the profit engine of the business, but also bring new things in and respond to changes in the strategic landscape. And that links to changes in technology. So you've been bringing in these technological advances, and this will help you compete. So another important factor is allocating time and resource to innovation. Do you feel that you had support from leadership, executive sponsorship?
Yeah. I think the good thing about an SME is I've found is that you have a short circuit to a decision maker. So it would have been 2 years ago now. I sat in front of my line manager and the managing director of the company and said, I think we've got this idea. I've seen it work elsewhere in a form, and I think this could allow us to really understand what's going on and when it's going on. I think the old saying is you can't manage what you can't measure, and at the moment all we had was quite, I dare say, old-fashioned production sheets with downtime comments, but it wasn't really giving me the visibility to say, when is this happening? Is it correlating with changes in feed material or whatever that may be? So we needed a bit more information. And with Gill Mill being sort of the flagship operation, as we were sort of saying, that the exploration had to be carefully managed, but the risk of the telemetry was just an information source. So we had to then think of targeting the solutions. For example, in your organisation, is there any specific digital technology that you've utilised to create value?
So one big change obviously has been digital marketing.
Okay.
Marketing has become the ability to access your customer, to communicate with your customer in different ways, very quickly and directly. That's changed a lot, and we've tried to leverage that, as many people have. So digital technology is not a target itself. It should be addressed as part of and in alignment with the business strategy. Digital needs to create value, needs to create new revenue streams or reduce costs. I think it needs to be integrated as part of all teams. So innovation is the introduction of an idea that could be new to the world or just new to the organisation, that's successfully leveraged to deliver value. So innovation management is really focusing on the innovation factors, the innovation boosting factors, to encourage it to happen in the first place, and then to guide it through to value creation, to cut costs, create new revenue streams, improve health and safety, sustainability, to create value. So innovation doesn't have to be the giant big steps, the radical things. It can also be the smaller incremental changes, small process changes, and I think that's something we've tried to integrate. So we're seeing more automation, allowing things like twin system controls that can make things like inspections safer. You can monitor much more closely what's happening with your plant, increase uptime, increase efficiency. There's going to be a lot of data produced by these new systems. Interpreting that data is going to become very important. Finding new efficiencies, building algorithms that can predict downtime. So there is funding, and there are tax cuts available for research
Yeah.
and development for SMEs.
Yeah.
It's quite simple to take advantage of that, and hopefully that will encourage more investment in research. It certainly has in some industries, and hopefully it is in the quarrying industry as well. Probably, as an SME, you've probably had experience of that, perhaps?
Yeah, well, we're looking at that shortly regarding certain elements of, for example, soil manufacturing and dealing with silt waste from the recycling plant, looking at different avenues in which we could use new methods in which to reduce its moisture content or essentially find a suitable home for it, which is a challenge that I think a lot of recycling operators up and down the country are finding a bit of an issue with at current. So.
The innovation value chain can begin with looking for ideas within the organisation. So you need to create an environment and an ecosystem for ideas to be generated where people have safety to express their thoughts, where there's where problems are thought about rather than just solutions, how to frame that problem. A climate where people are happy to make mistakes and experiment and have diverse kind of perspectives, diverse knowledge, bring different ideas to the table. So when you, in the beginning stages, when you were making your operational improvements, can you give any examples of how the team came up with ideas in-house?
Yeah, I mean, I think sort of the old saying, the best ideas come from the shop floor is still very much true. But in sense of the innovation management, when we installed the telemetry onto the plant, which was a relatively innovative thing for static plant processing, we identified various different bottlenecks and reduction in throughput, and then essentially we tried to focus in on what we can do to solve that. So essentially we used a lot of expertise from our OEM, the plant supplier, CDE.
So that links well with another stage, which is you're going to be looking for ideas outside the organisation, and how you're going to build networks to bring new knowledge in.
Yeah.
So you were looking to suppliers.
So that was our sort of we put the telemetry in, and then after that we actually arranged it was sort of a bit of a one-off thing. We got the specialist engineers from CDE to come to do essentially an optimization visit, so we could show them the elements in which we were finding troubles, whether that be blocking feeder trays or blocking chutes when we took the tonnage up. And they came up with solutions, some of which are longer term and require more capital investment, and some of which were simply isolating the plant, undoing 4 bolts, dropping the inclination of a feeder tray from 6 degrees to 8 degrees, firing the plant back up, increasing the throughput, and we solved the problem. So this is quite a wide-ranging scope of things that it doesn't always mean it's going to cost a lot of money. That's what I'm trying to sort of get at. And that's maybe one of the barriers that we might obviously come up against later in terms of innovation, that it's expensive and that it might not always deliver. Well, we found various cases where that case, for example, the blocking feeder trays, that paid back the cost of the telemetry within days in increased throughput.
From an organisational perspective, you need to move away from digital siloing. Having just one digital team is not really going to be enough. You're going to need to apply digital across the whole organisation, develop skills across the organisation to actually leverage technology. Within your team that started to look at the problem and look for solutions, would you say that you had good participation? Did you take steps to encourage people to bring their ideas forward?
Yeah. I mean, from the sort of the outset, starting with the telemetry, because for it to work, it has to have input from human beings. because essentially all that you get is you get a throughput line or a metric, whether it be utilisation or availability, and that's what it gives you. Where the human element gives you the reason why that's taken place. So it was absolutely essential from the outset when we first started looking down this route that the operators were fully engaged with the system, which thankfully they have been from the outset. They understood why we were doing it and how it actually makes everyone's life a lot easier, because they're not having to put themselves in situations that we don't want to be putting people in at this day and age, due to manual handling or whatever it may be. These engineering controls alleviate that.
So with bringing in the new technology, digital processes, one of the things that will need to happen in order to leverage the new potential is upskilling our staff, upskilling people, digital skills uplift basically. So this could be digital literacy, it could be specific software that's being used, or software languages even, security of data, digital security. It could feed to marketing, automation of marketing and social marketing. There's algorithms and statistical interpretation, which is probably very relevant to what you've been doing. Software development, software solutions to practical situations. Something probably relevant to you again as well is remote work systems, automation, AI, machine learning, interpreting that data that's being created by the automatic machinery.
I think it's no secret that the quarrying industry is somewhat quite staid, that I've recognised in my time in the industry. We have a workforce demographic that may not always engage with new upcoming technology. So one thing we've sort of found to do is select individuals that we feel would benefit and align directly, and that's something we have done on site with some of these principles of trying to increase performance via technology. So there were various individuals that we sort of identified and essentially promoted to fully take ownership for their operation in relation to ensuring that this system, the telemetry system, worked. And if there was a problem, they'd come to me and we'd try to sort it out. Another thing to try combat maybe a resistance to engaging with technology was one, and this was something that we pushed from the outset, was to make it simple. So when the guys have, and they do all they have mobile devices in which they can use and input data, it's simple for them to do that. If we make it difficult, it's another barrier for it not to happen. So it was really key that when the performance graph was on the visual on the phone there, it was really key that they could just tap on there and it'd come up with annotated comment, and they could input from a list of downtime failures, whether it be motor breakdown, lack of feed, block chute. There's a few sort of prompts in there, and then there'd be a comment box, simply what exactly it was. At the end of the month, I get a report of all these different things that have gone wrong, and then we can align resource for the top 3 for that month, for example. And some of the examples that we've discussed before, these engineering controls or sensors or whatever it may be, and flashing lights to indicate low throughput, were the top ones that was sort of working our way through in a methodical way.
You don't just want the next big idea, you want to make innovation part of the mentality of the company, part of the culture. Did you manage to do that?
We're getting there.
Yeah.
We're getting there, I think. I think it's probably a little bit like the principles behind health and safety. It's sort of a journey, a continual process. I don't think you suddenly just get there. But definitely, yeah, we have the business engaging in this information because it's now it's showing fruits. It's showing us information that we probably knew about, but we couldn't quite fully put a number on how much it was costing us.
So another important factor is to have ideas synergize, to mix together different perspectives, to create something different, so people bring different things to the table. And one way to do that is to build teams that are cross-functional, so you draw people from different parts of the business. They'll have different ideas, different perspectives. Did you do that in your business?
Did we?
So did you have people, operators from different departments within the business, come and help?
Yeah, I mean, essentially we have a. We didn't do it cross-functionally in that we'd, for example, have bring the sales team in or someone quite remote from the operational side, but we have an engineering department, an internal engineering department, in which we involve them heavily in finding solutions for various problems. And again, we looked externally to local contractors, all the way up to the majors for. Because these guys, from my experience, they don't just see one operation, they'll see similar problems all over the country, or if not, from CDE's case, all over the world. So it was key that we, well for me, that we utilised both the internal expertise of the guys on the ground, but also to try and actually find the solutions in different, for example, wear liners or high slip wear liners, or for example, at the moment we've just recently fitted chromium carbide wear liners in all the chutes because it's extremely hard wearing, and that's come from an external supplier who's identified this at a different site, and we've managed to utilise that knowledge. So I think one of the key things there was there was an element of sort of cross-functioning internally, but more so we sort of looked outwards of the organisation to try and understand where we can identify and find solutions swiftly for the problems.
So learning networks can make innovation more successful, and that's something that the IQ can help with, because they create these contact points, they create networks, and give you the opportunity to take part in networks and bring diverse external ideas into your firm. So I think IQ can contribute to the innovation process in the industry and in businesses.
Absolutely, yeah. I think it goes back to the point of when we were looking at the problems. If you've through an organisation such as the IQ have got links into different operators doing similar tasks and coming up against similar challenges, it short circuits that process of trial and error, because they can say, well, actually we've used this product, or we've used this supplier, or we've changed this around, or whatever it might be, and we've increased throughput by X percentage. I think that's key to be able to push things forward.
So the IQ's brought out the concept of the skills wheel to broaden the skills in the industry and to offer training pathways. And I think that helps with innovation as well, because you want something called T-shaped people, which is they'll have a broad knowledge, but also a particular depth of knowledge as well. So they'll be bringing a lot of ideas, a lot of different background across.
That's a really good concept, that, yeah.
So they'll have a broad background to draw from, but then each people might have one particular depth. So it might be engineering, it might be marketing, it might be the particular mineral. And that's something the skills wheel, I think, can help develop. Yeah. Do you think that could help you in your business?
Yeah, absolutely. Yeah, absolutely. To have somebody who has a specific, an overview and an understanding of the business of you're operating within. However, they have a specific strand within that they are an absolute expert in. Definitely someone to come in and offer expertise. there's got to be some mileage in that, absolutely.
Mm. I think in applying some of these new technologies, there are certain soft skills as well which are going to become more important. Again, that links back to the skills wheel that the IQ's developed, I feel.
Yeah.
Aspects like collaboration, critical thinking, creativity, complex problem solving, and being adaptable is going to become more important in leveraging the technological solutions. So the IQ offers the technical evenings, other branch events, a community, networking,
opportunities,
sources of information where you can learn more about new technologies, where ideas can be shared. This is useful for you finding new technologies for building your external sourcing for innovation.
Yeah, I mean, essentially from a quarry management 8-1 appointed position, I find the technical meetings very useful, where you've got, from a sort of a health and safety perspective, you've got industry experts and the health and safety inspector themselves to discuss hot topics and areas of focus. And I don't think there's a single person in that room that doesn't go back to their operation and challenge things and ask questions of, are we doing this and are we compliant, are we not compliant, what do we need to do about to sort it? And that is definitely something I certainly never leave thinking all bases are covered, that we need to always be challenging the status quo in relation to whether it be environmental or more so with the technical meetings, health and safety compliance.
And I guess when you're making these connections with other sites, maybe even other industries, then you might be able to bring an idea that's new just to your organisation, because innovation doesn't have to be new to the world.
And I think that's been more prevalent with working for an SME, because you can really, it allows you some form of a bit of a canvas really to guide things in a way where there's not a formal structure as there would be in a large PLC. So you can cherry pick really good practice and implement it in the best way possible.
An important aspect is to balance the long term with the short term.
Yeah.
Do you have, what's your next plan, Jeff?
I think,
your next one?
we've sort of, the business as a whole is looking at ISO 14001 accreditation. So we're sort of really trying to push the information that we've been getting to align that with some of the principles of ISO 40001, energy management, sustainable operations. So, for example, the next sort of step is another metric we're going to incorporate is sort of kilowatt hours per tonne. So, for example, how many tonnes are we producing for, or how many kilowatts do we produce for every tonne? We use for every tonne.
So sustainability is going to be a big driver for change.
So hopefully that's sort of the future of where I see the Gill Mill telemetry project going, is we've still not down the sorted out all the issues operationally that still are cropping up. We've sorted out probably maybe 60-70% of them. There's still more to overcome. But I think longer term, in the medium to long term, it'll be bringing in energy data and overlapping that over throughput. So part of the long-term restoration plan for the Gill Mill operation is to essentially we'll have the largest reed bed in the south of England, and to achieve that we need to restore various contours of the reed bed very accurately, extremely accurately in fact. So we have invested in a system in which is connected to the dozer, and it allows the dozer operator 2 parameters in his cab, and they essentially give him information of when he's on design or off design. So essentially all the separate contours align with the exact design that was approved under the planning permission with collaboration from the RSPB. So essentially it makes things more efficient because you're not double handling material if it's in the wrong location. I'm Ben Strickland and thank you for watching this IQON film about the use of technology in the industry. If you have any comments about this subject, head to the Institute of Quarrying page on LinkedIn using the hashtag IQON. Like and subscribe to the IQ on YouTube to be kept up to date with future programmes.